This is the presentation of the second mF2C project use case called SmartBoat. We'll go through the 4 steps. First, we'll describe a single boat deployment. Then we'll describe the software installed in devices. After that, we'll present the Android application, which is the dashboard providing a SmartBoat overview to the user. And at the end, we'll also demonstrate the SmartBoat alerts issued here on this setting, and we'll see the notifications on the Android device. At this moment, we have 2 lab deployments of the ship that you can see here on the table. In this setting, we have the Sentinel boat monitor device. This device is powered by 12 volts when charging, and it has some autonomy due to the included battery. The device collects sensor data as battery voltage, door hatch and GPS, which we use for issuing alerts and tracking the ship. Next device is the Raspberry Pi. It's ordinary Raspberry Pi 3 with attached LED lights for notifications. There is a development board also for the LoRa communication. This device is used to wirelessly connect to the Sentinel boat monitor and collect sensor and tracking data and process it. Then we have Sentinel router. This device enables the LTE and 3G, 4G connection to the cloud with the SIM cards which are included in the device. It also provides Wi-Fi and Ethernet network to the boat. Next, there is an Intel NUC, an additional computer to provide extra computing power to the Raspberry Pi. One setup uses NUC and the second one uses the laptop for the extra computing power. To track additional sensors, we use 2 Sentinel sensor hubs. These devices can attach to additional cables as input and wirelessly transmit the sensor data to the boat monitor using Bluetooth. To run everything, we need a power supply box. In this power switching box, we have additional batteries. Here is an ordinary battery pack to power the Raspberry Pi, and also some step-up converters that allow us to power the Sentinel Wi-Fi router and the boat monitor. The battery extends the autonomy of the setup for a few hours. From the software perspective, the mF2C agent is installed on the NUC device and laptop on the other ship setup. On the laptop will be the leader, and this NUC presents a non-leader agent. As the software is modular, part of the software is deployed on NUC and part of our SmartBoat application is also here on the Raspberry Pi. Raspberry Pi plays an important role because it holds all communication libraries for the Bluetooth communication that is used for reading the sensors. These 2 devices, Raspberry Pi and NUC, also serve services as Android backend. Now you can see 2 mobile devices on the screen. The left one will be the user of the ship and the right one will be the owner of the ship. The views are similar. The main difference is that the owner of the ship is able to monitor all his boats that he owns, while the user usually sees just the current boat that he is occupying. Here, with the app, we can navigate through the fleet view. This is the list of the boats. For the specific boat, we can see its location on the map. The app can show also the old tracks, selecting from the specific period. The component status presents which components are used in the setup. This representation of the icons presents similar situation that you are able to see it on the table. Next, there is a sensor list where we can find all sensors available on the boat. For example, we can navigate through internal battery voltage. Graphs can help us to review the history values, and similar view is available for all other boat sensors. Okay, now we'll have the alert demo. In the alert demo, I will trigger the alert manually, here with the cables. The levels will be detected by boat monitor. The Raspberry Pi collects the data from the boat monitor, and in a few seconds, when the alert is received and recognized, the LED lights indicate the alert, which at the end will be shown on the Android app. Now I'll trigger one alert, and as seen here, Raspberry Pi already collected the alert and the notification already reached the application. I'll trigger another one. Sometimes we need a few seconds to get the result. Okay, now we see the result. The alert is also shown on the Raspberry Pi. Android application allows managing alerts, so when they are processed by the users, they can be deleted. This is all from the Smart Boat use case presentation. Thank you very much.